Today we're going to look at section 2.4, truth tables for the conditional and biconditional. So a conditional is a logical statement of the form if P then Q. This conditional statement is in logic is a promise or contract. The only time a conditional statement if P then Q is false is when the contract or promise is broken. The truth table for a conditional statement below summarizes the results. So looking at this, what do we see? We see the only time it's false is when the first statement is true and the second is false. Because the contract is, if you do this, I'll do that. And then what happens is they did it, but I didn't do what I said I'd do. I broke the contract, it's false. So let's look at some of this. Assume P is true and Q is false. So we're looking at a particular instance. P is true and Q is false. So first we want to look at P then true, 2, or P then Q. Well, as you see, if P is true and Q is false, then this is false. Okay, then we're looking at P then not Q. And all we're looking at is one particular example, when P is true and Q is false. So P not Q would then be true here. So true then true, this is a true statement. And then we need not P here. And now I'm saying not P, if not P, then Q. False, then false. Right here. That's a true statement. The only time the conditional is false is when the first is true and the second is false. So let's look at a truth table for some things here. And we're going to put this all together. So what do I need? Well, I have two statements, P and Q. And we can go ahead and set up the standard true, true, false, false, true, false, true, false. Now I'm going to get ahead of myself a little bit here. I need not P. So that'd be false, false, true, true. Okay, and then what do I need? Do I need a not Q? I don't need a not Q. I do need a not P or Q. Remember, in the conditional, this part comes first. And that brings me to if Q, then not P or Q. So not P or Q. When one is true, it's true or statement. So I have not P and I have Q. Well, Q is true here, so it's true. Neither of them are true here. Both are true here. And not P is true here. So now I'm looking at if Q, then not P or Q. So now I'm looking at Q and not P or Q. If one of them is true, or if the first one is true, like here, the second one has to be true as well. First one is false and false. Well, that's true as well. True and true. That's true as well. True and true. So this is a valid statement. I don't know that. Yeah, it did. So number one is valid. Now looking at what we have here, I have not P. I have Q and P. I need, or Q. I need Q and P. So Q and P, that means they both have to be true. Only one time that's true, and that's right here. And the rest, it is not true. Now I'm looking at not P, then Q and P. So now I'm looking at not P, then Q and P. So is there any, and it's a if then, so is there any time when not P is true that Q and P is false? So not P is true here, false. So that's a false statement. True here, false. That's a false statement. Every other instance is true. And that means this is not valid. Okay, now let's look at biconditional. Biconditional, if and only if P, if and only if Q, or Q if and only if P, is a two-way contract. It is equivalent to the statement if P then Q and if Q then P. A biconditional statement is true whenever the truth value of the hypothesis matches the truth value of the conclusion. Otherwise, it's false. Truth table for biconditional is summarized below. So here we go. If they're both true or they're both false, it's true. So true, true, true. False, false. Otherwise, it is false. So let's look at this series here. And we're talking a specific circumstance. P is true, Q is false. So P if and only if Q. Are they both true or are they both false? No. So this is false. Okay, what about not Q? It would be true here. So P if and only if not Q. I have true and true. So that's true. And then we have not P, which would be false. And then we're looking at not P if and only if Q. So we're looking at false and false. So again, it is true. Keep in mind by the biconditional, P if and only if Q is true whenever the truth values of P and Q match. Otherwise, it's false. So again, we're going to put all these four together into one truth table here. And I have three. So I have P, Q, and R. And the easiest way to do this standard listing, true, 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 false, 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 false. Oh, four trues, four falses. Then I have true, true, false, false, true, true, false, false. And here we just alternate true, false, true, false, true, false, true, false. Okay, I also need not P and not Q. Not P, false, 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 true, 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 true. Not Q, false, false, true, true, false, false, true, true. Now we can get to up, and I need P and Q. P and Q. Are they both true here? Yes. Here, yes. No, no, and no for the rest. Okay, so now let's look at this. And I'm just going to put the numbers here. Number one. So I have not P or Q. And I have not P or not Q. So when is P and Q true? Only when they're both true. I have it right here. But we're looking at the negative of that, or the negation. So in that case, all these instances where it's false is going to be true. And then we're looking at not P and not Q. Let's start off with a rather complex one here. So not P and Q is true for the bottom six here. Now we're looking at not P or not Q. So anytime one of them is true, it's true. So these four are true. And then so the same six are true. So if it's true, true, it's true. And then we determine that it's going to be false, false. Oops. And for biconditional, false, false is true as well. So that means that this is valid. We got all true statements. All true signifies valid. So now I'm looking at not P if and only if Q and P. So if not P is true, P and Q cannot be false. I'm looking at these four here, where it's true, it seems that P and not Q is false for all of them. So that means we're looking at, and this is number two. Those four are false because this is true, not P is true, and P and Q is false. And for the rest of them, we have not P is false, which means they're true. If the first statement is false, doesn't matter the second statement, it's true either way. Okay, so now let's look at number three here. I didn't think this out very well. Let's see. So I have a conditional, then I have a biconditional, then I have an or statement. So let's see. We'll start with our or statement. And not P, Q. When is not P or Q true? When one of them is true. So we've got these four again. And then we've got these two. I think I might be not P or Q. We have create a new table here. And we're looking at P and Q. True, true, false, false. True, false, true, false. Okay, I need not P. Not P would be false, false, true, true. I need not P or Q, which gives me true, false, true, true. And I need if P then Q. And we have true, true, which is true. True, false, which is false. True, and true. Then I have the biconditional. If P then Q. If and only if not P or Q. So I'm looking for a false true. Here's my only false for the first statement, and it's false. So this is true, 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 true. This one was not valid. Number 3 is valid. Now let's see. I'm going to this because that's been what the problem is. I've been doing P and Q and including R, and I didn't need to. So here I have P and Q, and here I have not P and not Q, or not Q. I'm also going to need this part here, A, and I'll label this part here, B. So let's look at not P or not Q. Well, I have not P, I don't have not Q. Yeah, I do, right here. So the only time this is false is when they're both false. So false, false, true, 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 true. All right, so now let's look at this part A here, which is P and Q. If P then Q, then R, which is going to give me, if it's true, false, it's false. So I'm looking for true, false. True, true, so true. True, false, so false. I have false, true, that's okay. All these are false. All right. This line was true, false, so this one is false. And all the rest of them, the first statement is false, so they're going to be true. Because remember, the only time it's false is when I have false, or if true, then false. So that's for that. Let's look at part B here, which is P or not Q or R. So not Q. When we do this from left to right, actually that's not P. Not P or not Q. That's right here. This one here. And then I'm looking at R. And this again. So I'm looking here or here. So if one's true, then we'll just look at R here. This is true, so it's true. They're both false, so it's false. Oops, I'm getting ahead of myself. Here we have true, so it's the rest of these are true. So it's true, 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 true. And then I'm connecting both of these with a biconditional. This one and this one. Biconditional is only false when it's true false. And as you can see, the only time our second statement is false is when the first statement is false too. So this would be all trues, which means that this is a valid argument. Okay, so that finishes up section 2.4.